Hello everyone, welcome back to another video. I know it's been long since I've said this sentence. There were a lot of things going on in life for good and I was very inconsistent in making videos, so I'm sorry. I'm posting after 5 months, but right now let's talk about this video. So in this video, I'll be talking about a very important topic, both for the exam point of view and for theory purposes. So even if you're not a pilot, if you're not in aviation, you can watch this video, and I would say you should watch this video. Why? Because it's on a topic called time, and this is something we use in day-to-day life. So most of us travel abroad and most of us want to know what is the time difference. So we need to know the time difference between, let's say, India and Dubai. We need to know the time difference between India, Bangkok, and so on. So in this video, I'll be talking about how to convert time from UTC, or the Universal Coordinated Time, to the local time. Local time is the time we follow anywhere on the globe using longitudes. So every place has its own standard time. We'll talk about what standard time is. We'll talk about how to convert time zones, as I just said. And if your concepts are clear, I'm sure you'll be very comfortable in the exams as well. And it is a concept which everyone should know because it is a very basic concept. Okay, so let's talk about why is this a very important topic for pilots. Let's say I'm flying to a new destination tomorrow, yeah, and that aerodrome is called Aerodrome X. Now I open the charts and I find a note there saying that there are no aerodrome lighting facility available on the airstrip. That means there are no lighting facilities available on the aerodrome. So what does this mean to me? This means that I need to land my aircraft before the evening civil twilight, or to be safe, I need to land before sunset. Now, how do I know what is the time difference between that place and between my home country? How do I plan my flight? Obviously, all this seems very easy because we have smartphones and all that. But if we do not have smartphones, if we have to manually calculate it, how to do that? So that's why this becomes a very important topic for pilots. Okay, let's start this video by taking up a question. Why do we have time zones in the first place? Why is it 12 p.m. in India but 2:30 a.m. in New York? What's the reason for this? Because if we don't know the reason behind time differences, how will we be able to find the difference in time? How will we be able to calculate the time differences? So let's dive into it. Let's talk about the reason why we have differences in time. So the reason behind time being different at different places is because of the rotation of Earth. Our calculations are also based on the rotation of our planet. So let's say the Earth is over here and we have the Sun over here. Now we can see that the places over here will have sunlight, whereas the places on this side of the Earth will not get sunlight at this very moment. But when the Earth is rotating, these places will also start getting sunlight. Why? Because the Earth will be rotating and these places will also go in the direction of the Sun. So the Sun's rays will be able to reach those places. And this is exactly why the time is different at, let's say, these two places, place A and place B. What we see when we compare place A and B is that place B will be ahead in time as compared to place A. So if it is 10 a.m. at place A, the time at place B would be, let's say, 12 p.m. Why is place B ahead of place A? Because place B got the sun earlier than place A. So place B started the day early, and thus place B is ahead in time or ahead in the day as compared to place A. And thus this is the reason why it is 12 p.m. in New Delhi but 2:30 a.m. in New York. Now, a very important concept you need to keep in mind while studying time is that the local time at any particular longitude will stay the same at different places which are on that particular longitude. So let's consider this longitude over here. Now, we see that the sun's rays are coming directly on this longitude. So, any place on this longitude, be it over here, or here, or here, or here, every place on this longitude will have the same local mean time. What is local mean time? I'll come back to this later. But right now I just want you to keep in mind that the local mean time at every place on this particular longitude will stay the same. It is true for all longitudes. So if I take this longitude right over here, places on this longitude will have the same local mean time at the very instance. Or a longitude which is like this, the local mean time of every point or every place will be the same. Alright, so the local mean time is the same along a longitude. Why? Because the sun is at the same position with respect to the whole longitude. So the time anywhere on a longitude will be the same. Now let's talk about what is local time. So the time that is based on meridians is the local time. Let's say this is the Earth and I'm talking about this meridian over here. Now, when my sun is directly over this meridian, the time everywhere on this particular meridian will be 12 p.m. or 12 noon. Why? Because the sun is directly overhead the meridian. And if I talk about its anti-meridian, so time anywhere along this meridian, which is the anti-meridian, would be 12 a.m. or midnight. So time anywhere on the meridian will be 12 p.m. and time anywhere on the anti-meridian would be 12 a.m. Now what is local time? So local time is the time based on longitudes. So if I look at this meridian over here, the time on this meridian with respect to the sun's position will be the local mean time at this meridian. The time anywhere on this meridian, let's say it is 1500 hours. So 1500 hours will be the local mean time on this particular meridian. So local mean time is the time along any meridian. If we talk about this meridian, let's say the time is 1700 hours. So 1700 hours will be the local mean time on this particular meridian. That is LMT or local mean time. I hope you're clear with this. Now let's talk about another term which is known as standard time. So what is standard time? Standard time is based on different countries. If I take an example of my own country, India, I see that the country is spread over a lot of longitudes, starting from 68 degrees 7 minutes east to 97 degrees 25 minutes east. Now, we all know that each longitude will have a different time with respect to the sun. Yeah, that's what was local time. So the time at this longitude would be different to the time which is over this longitude or over this longitude, over this longitude, and so on. So the time over every longitude would be different because the sun's position is changing. But if you think about it, running a country with so many different time zones would be a very difficult task. So different states would be using different time zones. Now what the government did was, they fixed a particular longitude for reference of the whole country's time zone. And in our case, this longitude is 82.5 degrees east. So this longitude was given by the government of India as the standard meridian. And the time which we observe over this meridian will be followed throughout the country. Alright. So whatever time is on 82.5 degrees east longitude will be observed anywhere on the country, be it in the eastward state or the westward part of our country. Right? This time, which is observed over the standard meridian, is known as standard time. Now, standard time is given by the government of a country. Every country gives its own standard time, just to make things more uniform and easier for the country. Now let's move forward. We know that the Earth completes its one rotation in 24 hours, right? That is the duration of the whole day and night, obviously. So in 24 hours, the Earth is completing 360-degree rotation. If I take any longitude and put the sun over this longitude, the Earth will rotate, the sun will go over different longitudes, and after 24 hours, the sun will come back over this particular longitude. This is something we all know. Now, what is the direction in which the earth is rotating? I always think about it this way. You would have seen this in my earlier videos as well, that the earth is over here and the sun is over here. We all know that the sun rises from the east, correct? Now, we also know that the earth is something which is rotating and the sun is stationary. So if I say that the sun is rising from the east, that means that my earth is actually moving in this direction. Why? Because the sun is coming on the earth from the east and sun is stationary. If I imagine a person standing over here on the earth, he or she knows that the sun always comes from the east. So the sun is coming from here. But since the sun does not move, it's the earth that is moving towards the sun. So when observed from here, I see that the earth is moving from the west to the east. Or when I observe it from the North Pole, so if this is an eye, if I'm observing it from the North Pole, I see that the earth is rotating in the anti-clockwise direction. Next, we just discussed that the earth rotates 360 degrees in 24 hours. So we can now use this conversion to convert angular arc to time. I'll break it up. So I'm saying that 360 degrees of earth's rotation happens in 24 hours of time. If I break this 360 degrees into 180 degrees, so if the earth was rotating 360 degrees in 24 hours, it will rotate 180 degrees in how much time? In 12 hours, which is exactly half. So that means that my earth is rotating 15 degrees every hour. So in every 1 hour, the earth rotates 15 degrees. If I break it up further, I can say that the earth rotates 1 degree in 4 minutes. Okay, very straightforward. Now, I know that 1 degree has 60 minutes in it. Yeah, so I can write this 1 degree as 60 minutes. So 60 minutes rotation of the earth is happening in 4 minutes time. Breaking it further, I can say that a 15-minute arc or 15 minutes rotation of the earth is taking place in every 1 minute of time. I do not want you all to get confused between this minute and this minute. Everything on the left is the angle that the earth is rotating, and everything on the right is the time it is taking for this rotation. Starting from 360 degrees 24 hours to 15 minutes in 1 minute. The most important one is this. So I want you all to remember this one. The earth rotates 15 degrees in every 1 hour. Now I'll tell you how to use this concept to find the time at different places. Let's say I want to know the time at place B, which is over here. Now I know that this place, that is place B, is on a longitude 15 degrees to the east from this place, which is place A. So the angular difference is 15 degrees. Okay? The change in longitude is 15 degrees. Now what do I understand from this? I know that the earth is rotating 15 degrees in every 1 hour. So the time it took from place B to place A with respect to the rotation of our planet is 1 hour. That means the time difference between place A and place B will be of 1 hour. Now using the other concept of which place is ahead in time. We all know that the sun rises from the east. What this tells us is that the sun was overhead B before it came to A. That means the day at place B started before the day started at place A, which further means that place B is ahead in time. So if it is 300 hours at place A, the time at place B would be more than this, which is 400 hours. The gap or the difference will be of 1 hour. 1 hour because the Earth rotated 15 degrees to go from place B to place A. All this is very easy if you try and understand it slowly. So we saw that the Earth was rotating 360 degrees in 24 hours. From this, we came to a conclusion that the Earth is rotating 15 degrees, or there is a change of longitude of 15 degrees in 1 hour. Okay, using that concept, I took an example of place A and B, which were on two different longitudes, and the difference of these two longitudes were exactly 15 degrees. So what this meant was that the time difference between place A and place B would be of 1 hour, and the place on the east is ahead in time because the sun is coming from the east. Now I'll go through a very basic type of question just to make sure you understood the concept, and then we'll move on to the systematic approach you should follow while solving these questions. In this question, we are given the local time at this particular longitude, and we are supposed to find the time in UTC. Now, time in UTC means the time which is over the Greenwich prime meridian, okay, or that is the meridian of 0 degrees east-west. If you remember from longitudes, that is the meridian we take as a reference to name all the other longitudes. So it is 0 degree longitude. Perfect. So let's draw a diagram. Let's say this is my Earth. This is the prime meridian, which is 0 degrees east-west. Now I'm given a longitude that is 75 degrees west. So west is this side. Let's say this is 75 degrees west. Now I have the time at this longitude. I want to find the time over this longitude. So the first thing I need to find is the change in longitude. What is change in longitude? If you all remember, change in longitude is the difference between both of these longitudes. So from this diagram, we see that the change in longitude is 75 degrees. The direction is not important right now. So 75 degrees is the change in longitude. Now what do I do with 75 degrees east? I know that the Earth is covering 15 degrees in 1 hour. So how much time will it take to cover 75 degrees? I'll just divide 75 by 15. It comes out to be 5 hours. So the Earth will take 5 hours to cover 75 degrees change in longitude. Now we know that the time on this longitude is 150 and the date is 3rd. We found the time difference. The time difference came out to be 5 hours. Now the blue place is towards the east. That means that place will be ahead in time. It got the sun earlier. So what will be the time at the Greenwich meridian? It will be 150 plus 5 hours, that is 650. And since the date did not change, it's just a matter of 5 hours. 5 hours got added up to the 150 hours, so the date remains the same. So the answer would be 650 on the 3rd. This will be the time in UTC. That's it, pretty easy. Let's look at another question, and now I'll tell you how to solve such questions by a more systematic approach. Okay, so in this question, now we're given the LMT at 84 degrees 37 west longitude, which is this 282216, and we need to find the time in UTC and the time in LMT at this longitude, which is 12 degrees 52 minutes west. So how to read time like this? The first 2 digits is the date, and the next 4 digits are showing the time in 24 hours format. So the local mean time at 84 degrees 37 minutes west is 22:16, which is 10:16 p.m. on 28th. Month is not important, it's just the date which matters. So on 28th, we're talking about 10:16 p.m. Perfect. So in this question, we have to find the UTC and the LMT at some other place. So we break this question into 2 parts. First part, we'll find the UTC. So how to begin questions like this? Just write whatever information you have. So we know the LMT is 2216 on 28th. Now what is the longitude? So the longitude is 84 degrees 37 minutes west. Perfect. What do we need to find? We need to find the UTC. Now we need to add or subtract something to this LMT, which is the local time, to get the UTC. We know that 15 degrees was covered in 1 hour. So 84 degrees 37 minutes will be covered in how many hours? Very easy way to do it. Just pick up your scientific calculators. Divide 84 degrees 37 minutes by 15. And you get 5 degrees 38 minutes. So what I did was, I divided this by 15 and I got 0.5038. Now, I'll either add or subtract these two times to get my time in UTC. What do? Do I add or subtract? So I make a small diagram. This is the Earth. I'm viewing the Earth from the top. So that's the North Pole. This is 0 degrees east west longitude, which is the prime meridian. And I'm talking about a longitude which is 84 degrees 37 minutes west. That means the longitude would be somewhere here. So this is 84 degrees 37 minutes west. Now, is the prime meridian east of this meridian or west of this meridian? Let's find it out. I make two arrows, east and west, and I know that the prime meridian is towards the east. Now what does this mean? This means that the prime meridian will be ahead in time. Ahead in time means that the time on the Greenwich meridian will be more than the time at 84 degrees 37 minutes west. So I add both of these and I get the answer in UTC. So what do I get? It is 538 plus 2216. I'm getting 2754. Now we all know that time is always expressed in 24 hours and there's nothing more than 24 hours. So if my time has gone past 24, that means that the date has changed. I'm talking about the next date. So first of all, I'll subtract 24 from this and it will come out to be 3 hours 54 minutes UTC on the next date, which is 29th. This will be my answer in UTC. So the first part of this question is solved and the time in UTC comes out to be 3 hours 54 minutes on the 29th. Next, let's look at how to solve the second part of this question. So now I have the time in UTC. I will write UTC 0354 on 29th and I need to find the time at 12 degrees 52 minutes west. So now if I use the same diagram, 12 degrees 52 minutes would lie somewhere here, which is the black line or the black longitude. Now what do we find? We find the angle it is making with the prime meridian and then we see if it is west or east of the prime meridian. In this diagram we can see that this is west of the prime meridian, obviously because the longitude is west. So how do we find the time? We divide this by 15 and what do we get? So we get 1252 divided by 15. We get 51 minutes. So the difference is of 51 minutes. Now since this place is west of the prime meridian, it will be behind in time. Behind in time means that the time at this longitude will be behind the UTC. So we'll subtract the time difference from 3 hours 54 minutes and what do we get? We get 3 hours 3 minutes on the same date, which is 29th. So that is how I solve these questions. It may look very complex, but if you think about it, if you go slow, all this is very basic. All they're talking about is the angular difference, and as you find the angular difference, you just divide it by 15 to find the difference in hours, because 15 degrees is covered in 1 hour by the Earth. Now there may be some questions in the exam where they just want you to find this or the time difference, and this is known as hour angle. So if there's a question which asks you to find the hour angle, don't get confused. They're just wanting you to find the change in longitude divided by 15 using your scientific calculator, and you get the hour angle, which is nothing but the difference in time between those two places. Okay, so let's look at a couple more questions for better understanding. Okay, so in this question, we're given the time in UTC, which is 1300 hours on 1st April, and we need to find the local mean time and the local date at this particular coordinate. Okay, so let's write whatever is important to us. We have the UTC, that is 1300 hours on 1st. We need to find the local mean time at this longitude. I do not care about the latitude because latitudes have nothing to do with time. It's just the longitudes which matter. Okay, we'll come to latitudes when I talk about sunrise and sunset, but right now we just look at the longitudes because our earth is rotating, and as it is rotating, the sun is overhead different longitudes and the time along a longitude is the same. We don't care about the latitudes. So we need to find the time at this longitude, which is 007 degrees 15 minutes east. What will be the hour angle? We just divide this by 15. So using the calculator, 7, 15 divided by 15. The difference I get is of 29 minutes. Now, if I want to know if I add or subtract, rough diagram. This is not even important. After some time, you'll feel stupid making this because you'll understand it just by looking at the two coordinates. And since it's the UTC on one hand, so it's obviously very, very straightforward if the other longitude is east or west. But it's okay, I'll draw the diagrams for your understanding. So this is 0 degrees east-west, and the longitude we have is 7 degrees 15 east. So it's over here, let's say. The time on the green longitude is 1300. What will be the time on the purple longitude? So the purple longitude is east of the green longitude because this direction is east and this direction is west. Now since it is east, the time there will be ahead. So we'll add and we get 1329. And since the day did not change, it will be on the 1st. So the local time at this coordinate is 1329 hours on the 1st. You see how easy it was? It is just going to take some practice and you'll be perfect with these questions. Okay, so let's now look at a question which people say is a bit more complex, but I find it very straightforward and I'm sure you all will be able to solve it quite easily. So it says that an aircraft leaves Australia at 2200 UTC on 4th and lands in Philippines some 6 hours and 45 minutes later. What is the LMT at landing? Okay, so you do not care about the places first of all. Just look at the longitudes because that's what we need. So Australia's longitude is 153.02 east and Philippines, Manila's longitude is 120.58 east. That's what I care about. Now, my aircraft is leaving Australia at 2200 hours and it is landing after 6 hours 45 minutes. Can I find the time it lands in Philippines in UTC? Yes. So let's say it is taking off at 2200, flying and landing 6 hours 45 minutes later. So what will be the time it lands? So if I use my calculator, it will be 22 plus 645, which is 2845. Now 2845 does not exist, so I subtract 24 hours. It will be 445 UTC on the next day. So if it was taking off on 4th, it's landing on 5th. Okay, very easy. Now I know that my aircraft is landing at 4:45 UTC, and in the question they want me to find the local mean time at landing. Okay, so let's write all of this in the format I told you. I have the UTC, which is 4:45 on the 5th. What is the change in longitude? So for change in longitude, this is a rough diagram. This is the Greenwich. I have the time on this longitude, which is 4:45. I need to find the time on this longitude, which is 12058 east. So it will be somewhere here. Yeah, I know the difference in longitude is 120 degrees 58 minutes. So I write 120 degrees 58 minutes. How do I find the R angle? I divide this by 15. So on my calculator, 120 58 divided by 15. It comes out to be 8 hours 3 minutes. Now, how do I know if I add or subtract? This side is east, this side is west. Now, since the red longitude is east of the green longitude, it will be ahead in time, and the time on the green longitude was 4:45. So I add 8 hours 3 minutes and I get the answer as 12 hours 48 minutes on the same date, which is 5th. So this will be the local mean time when my aircraft is landing in Manila, Philippines. Now if I just want to go over this question again, I had the flight time. So the flight time was 6 hours 45 minutes. I had the time my aircraft took off in UTC. So I easily just added the flight time to the time of departure and I got the time at which it landed in UTC. Now I had the time in UTC when my aircraft landed. I just converted that time to the local mean time by using the R angle. So my R angle came out to be 8 hours 3 minutes, and I knew that this place is east of the prime meridian, so the time will be ahead. That means I need to add the R angle to the UTC time, and when I did that, I got my answer to be 12 hours 48 minutes on the 5th. So my aircraft is landing at 12:48 hours on the next day. It took off on 4th May with respect to UTC, and it's landing on 5th May, which is the local time. Perfect. Let's now talk about sunrise and sunset. Now, a fact we all know is that when the sun is over a particular meridian, it is noon, or the time is what? 12 p.m. Yeah, this is the local time because the time based on longitudes is always local time. Now, when my sun moved to this longitude, what was the time over here? The time here was also 12 p.m. When my sun moved to this longitude, the time was 12 p.m. This longitude, 12 p.m. and so on. So whenever my sun is over a particular meridian, the time over there is 1200 hours. So what I can say is that local noon occurs at the same local mean time on all meridians. Yeah, so the local noon always occurs at 12 p.m. be it any longitude. Now another fact which is connected to this one is that all longitudes which are on the same parallel of latitude will have the same time of sunrise and sunset. Obviously the local time. So all these places on this particular purple latitude will have the same time of sunrise and sunset. So if the sun is rising at, let's say, 500 hours on this place or on this longitude, it will rise at 500 hours at this longitude as well. Same for this longitude and for all longitudes in fact. The condition is that all these places should be on the same latitude. Okay, so local noon at same LMT on all meridians. Sunrise/sunset also happens at the same LMT on all meridians, but those meridians should be on the same parallel of latitude. Now I'll use this concept to solve another type of question which you can get in the exam, which asks you to find the sunrise or the sunset time. So the question says that the sun rises at this coordinate at 6:54 UTC on 25th. on the same day, what time does it rise at this coordinate? The first thing I need to see is that if these points are on the same latitude or not. So let's compare the coordinates. The first point is on a latitude of 50 degree north. What about the second point? Yes, the second point is also on the same latitude. So that means the LMT will be the same. This makes things very easy for us. We have the time in UTC at which the sunrise was experienced at 25 degree west longitude. So UTC is 0654 on 25th. Okay, so I have the UTC. Can I find the local mean time? Yes, I can. So what will be the hour angle? This is the Earth, Greenwich meridian, 0 east west. What is the longitude? It is 25 degrees west. West is on this side. This is 25 west. So what will be the angle? Angle is 25 degrees because longitudes. So 25 degrees west. I divide it by 15 to get the hour angle. So my hour angle comes out to be 1 hour 40 minutes. Now, this side is east, this side is west. The blue longitude is west of the Greenwich meridian. That means the Greenwich meridian will be ahead in time. Since it is ahead in time, the blue meridian's time will be behind. So I will subtract 1 hour 40 minutes from 6 hours 54 minutes and I get 5 hours 14 minutes as the LMT. Okay, 5 hours 14 minutes is the local mean time when the sun was rising on 25 degrees west on 25th. Okay, so I've done nothing. I've just converted the UTC to LMT right now. Now, I need to find the time in UTC when the sun will rise at 40 degrees east longitude. Now, how do I go ahead with this? Till now, what I know in the question is that the sunrise was at 5:14 LMT on 25 degrees west longitude. I know that both of these points are on the same latitude. That means the LMT at which I experience sunrise on 40 degree east will be the same. So LMT will be 5 hours 14 on 25th because we're talking about the same day. Now what will be this time in UTC? So what's the coordinate? It is 40 degree east. I write it here. Divide by 15. I get 2 hours 40 minutes. Now, if I use the same diagram, this would be the longitude, 40 degree east. I know that this longitude lies east of the prime meridian. That means it will be ahead in time. So the time in UTC will be less. So I subtract this and what I get is 2 hours 34 minutes on 25th. And this is my answer in UTC. So this is the time in UTC when the sun rises at 40 degree east on 25th. Okay, so if I go over this question again, I had the sunrise time on 25 degree west longitude in UTC. What I did was I converted that to LMT. Why did I convert it to LMT? Because I know that this LMT will be equal to the local time when the sun rises on the other longitude, which was 40 degree east. Why will it be the same? Because both of these places are on the same parallel of latitude of 50 degrees north. So I found the LMT. The LMT came out to be 5 hours 14 minutes. Next, I knew that this is the local time at which sun will rise at 40 degree east longitude as well. So I took the LMT to be 5 hours 14 minutes and I just converted it to UTC. To convert it to UTC, I had to find the hour angle between the new longitude and the prime meridian, which was 2 hours 40 minutes. Because the change in longitude came out to be 40 degrees, I divided it by 15, I got 2 hours 40 minutes. What I saw was that this longitude was east of the prime meridian and thus it would be ahead in time. Since it is ahead in time, the time in UTC will be lagging behind. So I subtracted 2 hours 40 minutes from my local time and I got the time in UTC as 2 hours 34 minutes. I hope you understood all these type of questions. Okay, so that was all about this topic. That was all about time theory. These were all the kind of questions I could think about, which could be a bit tricky. I don't know why people call that big question difficult. Probably they just look at the number of lines and they're like, oh, there are 4 lines, it's going to be difficult. But believe me, whatever question you get, just divide that question into parts. Let's say you have a question where you have to find the time at this particular longitude and you have the local time at this particular longitude. How to go through this? Divide it in parts. First find the time at the UTC, or first find the time at the Greenwich meridian. Then in the next half, calculate the local mean time of this longitude using the UTC. So that is how you will divide the question into halves. There is one way to find the time directly. So you have time in this longitude, you want to find the time in this longitude. Just find the angular difference and just apply your concept. But I like to go systematically. So if I was in your case, I would find the UTC first. From the UTC, I would find this part. So just try and make things easier for you. Just make smaller steps so that mistakes are less. And I'm sure you'll do wonders in the exams. This is not a very big topic. This is not a very, very difficult topic. So you'll get 2 or 3 questions in the exam. And if you know the concepts well, if you know that the place is east, it will be ahead in time. The place is west, it will be behind in time. You'll be good in the exam. So best of luck, and I hope this video helps you. Thank you. I'll see you next time.